Hello everyone. Today we are going to talk about self-driving system. The members of our group are Hishan, Ying, Percy, Christine, and Uzman. We are going to talk about software, hardware, effect of it on society, and some accidents of it.
Autonomous vehicles, some predict, will replace many of today's forms of transportation and radically expand mobility by allowing people, including the young, old, and disabled, to get around without having to walk, without having to know how to drive, and without having to wait for a bus or train. Operating without a driver and using electricity for power, the autonomous vehicle could be cheap to operate and environmentally friendly. It could in fact replace car ownership for many households. The progress towards autonomous cars has accelerated, and companies from Google to BMW to Volvo to Uber suggest that they will be able to offer such vehicles relatively soon.
Hello everyone, my name is Ying. I'm going to talk about hardware on autonomous car. There are several important components on self-driving car. LiDAR, computer cameras, odometry, radar, and computer. LiDAR is a survey method that measures distance to a target by illuminating the target with a laser light. On self-driving car, there's a LiDAR on the top of the car. It can scan the situation around the car with a radius of 60 meters, and it can show the result as a 3D map, which gives the computer the preliminary data. And there's a camera in front of the car, which is used to detect the traffic light. And also, with the help of computer, it can distinguish the moving object, which is a person, a bicycle, or a car, so that the car can distinguish them and then do the correct action to avoid the car or something like that. And self-driving car uses an important method, which is odometry. Odometry is the use of data from motion sensor to estimate the change in the position over time. So it has a sensor on the left back wheel, which is used to locate the correct position of car on the road according to the horizontal movement of the car, which makes the car's position more accurate on the road. Radar is an object detection system that uses radio waves to detect the range, angle, and velocity of objects. And there are 4 radars on self-driving cars. 3 are in the front and 1 is at back. They are used to measure the distance with each object in front of the car with the help of the computer and the front camera. The most important component of an autonomous car is definitely the computer. It is installed at the back of the car. It collects the data transmitted from devices described above, and according to those data obtained, it will determine the routine and action of each car. And then Percy will discuss software on autonomous car with you guys.
Hi, my name is Percy, and today I will be talking about the software in auto-driving system. Software is a very important part for auto-driving system. It includes a lot of complex algorithms and the interaction between interfaces. So how do the researchers of companies like Tesla and Google involved in auto-driving system to find the optimum algorithm? Most of them are working on the common 3-step strategy. That is perception, planning, and controlling. Perception involves the interaction between hardware and software. Like sensors will catch the objects outside of the car and send a signal to the hard software so that it's a step of perception. After received the signal from the sensor, the software will be searching the problem on an online cloud. After reach that problem, it will make a decision on load map with different situations. It's kind of like that the computer is playing a driving game. So it is making decisions step by step successively. And for controlling is that the car will follow the decision in planning with reaction for instantaneous change, like the traffic light. Software for autonomous car is not yet complete. A considerable number of tests have already been done on it. However, most of them have been tested on limited environment. The type like Tesla Autopilot can only be used on limited access highway. Among other limitations, Autopilot cannot detect the objects on the road. Under this limitation, however, it still caused some accident, which will be talked in later in this video. So it's maybe comfortable to say that the software for auto-driving system is still not a mature topic, and we still need a lot of researching, experimenting, and experiencing on it.
Transportation engineering, aka transport engineering, is a subdiscipline of civil engineering, application of technology and scientific principles to design, operation, and management of transportation. Examples of divisions related to public transportation: air, highway, waterway, and urban transportation. Relation to urban planning. Closely related through city layouts, residential and business locations, locations of highways, train tracks, etc. Autopilot. Widely used in today's plane operations. 2.5-hour domestic flights already uses flight management systems to do 95% of the work. Trains. ATO, automatic train operation, is an operational device and system to help automate operations of trains. Already commonly used around the world for train systems. Examples: New York City subway system, London Underground subway system, Vancouver SkyTrain. Auto-driving buses. Technology surrounding auto-driving buses are more closely related to auto-driving cars and much more complex than trains and airplanes, not expected to be widely used in the next 10 years. Challenges of auto-driving and public transportation. Although statistically safer than traditional driving, many passengers still are hesitant about boarding public transportation with no human driver. Humans have better reasoning skills than robots and are able to process information from multiple sources quicker with better efficiency. For public transportation such as planes, buses, and trains, only one driver is needed for many passengers. The cost of developing further technology in auto driving is probably not worth the marginal benefit in safety and cutting costs of hiring drivers.
The field of autonomous vehicle is a branch of study that requires highly skilled engineers from all other fields. In their biggest ambition to always innovate, engineers usually find themselves very often making some huge mistakes, creating other problems while trying to solve some problems. Despite being extremely cautious on the safety of people, we usually assist at many accidents, consequences of some engineering errors. A striking example of self-driving cars accidents which cast a doubt on society on the safety of autonomous cars is the two incidences that happened recently. One on September 23rd, when a Google self-driving car on self-driving mode sustained a significant damages after it met an accident while traversing the street, and the other on May 2016, when a man was killed after his Tesla, operating in autopilot mode, hit an articulated lorry, which created fear within society. However, for engineers, these failures are just the beginning of a new ever revolution. Hussein Dia of Swinburne University of Technology said, "The Tesla accident could shake consumer confidence, but is unlikely to slow the momentum of self-driving technologies. Taking all that into account, as an engineer, I realize that the word safety depends on my performance, on how careful I am in my projects. It's important for me to notice the importance of what I'm doing and my duty to make sure that I don't put the life of the society in danger. Success comes from making correction of our mistakes. In spite of making mistakes, what really makes the engineers always go forward is their ability to learn from their mistake, to improve, and their willingness to always serve good to the society." Thank you all for your attention and time.